kitchen table of Hampshire College astronomer Dr. Salman Hameed, Mr. Universe, back from your home country of Pakistan. How was your trip?
Trip was great. It was a short trip. It was for a few days, basically, including travel and everything. I mean, I was back within a week.
Yeah.
And I love it.
The first time I went to India was only for like a month, and I had jet lag for the majority of time I was in India, and then for like a month after I got back.
And I thought that you was gonna say that it's been years, but you still have jet lag.
I still have it now.
I think.
But we're back to talking about astronomy, and tonight is something that we wish we might be able to see, but given how cloudy and rainy it's been, we probably wouldn't have been able to see it anyway, and also given where we are on the globe, we are not going to be able to see it. But there is the eclipse of Broadway and Hollywood sensation, Beetlejuice.
The Broadway one never gets eclipsed. Let's put it this way. There is there's an asteroid passing in front of a star. So normally you have a solar eclipse, a lunar eclipse, but Betelgeuse is big enough actually, and not like big as the sun, but as a star, this is one of those really unusual instances where a tiny asteroid is actually going to be passing in front of it. The asteroid is in our solar system. Betelgeuse is farther away, and these kind of eclipses give fascinating information about the star that is being eclipsed.
Because you can see the same thing we talked about before, the spectroscopy, the different colors that show up when it dims in the light. Or what do we learn? What could we learn about the eclipse of Beetlejuice tonight?
Well, because there is an eclipse, so you can see sort of like the real edge details. So, for example, Betelgeuse is one of those stars that can be resolved, meaning to say you can actually see the disk a little bit from telescopes, which for most stars you cannot. In fact, almost all of the stars you cannot, and there are only few stars. Betelgeuse is one of them, so it can actually provide information about the star itself in terms of what is happening on the edges of the star itself.
No star will eclipse Michael Keaton in my mind. He is great. He's going to be in Beetlejuice 2, which I think is a horrible decision, but maybe it'll be great. Speaking of stars, and speaking of supernovas, which Beetlejuice is clock's ticking. Sometime in the next, 10,000 years, we expect Beetlejuice is going to go supernova?
Probably, or 100,000 years. But yeah, that is a star that is going to go supernova. That is a star that is only about 600 light years away. It's going to be a spectacular show. When it goes, it's going to be, the estimates are, it might be as bright as the full moon. And so it will be really cool. When it's going to happen, we don't know. And I know everybody says, well, what if it has already gone off? Sure. But when we are talking about it is, when we think in terms of light, it's getting us today.
Yeah.
Right? So whenever it may have already happened, sure. But the point is it's going to get us while we are alive.
Mm-hmm. I hope so.
And with climate change, actually, I don't know how long, but
Oh,
no, sorry, I didn't want to bring it down. But yes, the likelihood is within the next tomorrow or 10,000 years, anytime in between.
And speaking of supernovas, that was hard for a Boston accent person to say, and climate change, we thought we were the ones who were going to destroy our atmosphere, but turns out the universe hates us too.
Well, for Boston accents, actually, they make it easy, and it's supernovae.
Okay, cool. More than one.
Right.
Supernova is the show that comes out of WGBH Boston, which is our parent company. So that is a super show.
Nice plug, Monte. Okay, so this is a story, I think we talked about it on your previous life or previous show, however you want to say that. And there was a bright gamma ray burst. So gamma ray bursts are, as the name suggests, these are very short bursts that are observable in gamma rays. These are some of the most energetic phenomena in the universe. And some of them occur when two neutron stars, these are dense cores of large stars, when they collide. Sometimes they also happen when a large star collapses first into a supernova, and then it collapses into a black hole. And before the material turns into or goes into a black hole, there are the material just spins out and and is sent out in two jets. And if the jet happens to be pointing towards us, we actually detect very bright gamma rays. And those are called gamma ray bursts. And so in last year, and that was in fact exactly October 9th, 2022, there was a really bright gamma ray burst that was detected, and in fact, it was dubbed the boat, the brightest of all time. and this, and again, just to give you an idea, what is amazing about this is that was from a supernova, 1.9 billion with a B light years away.
And that is the brightest thing we have observed. That's not like our sun or a star close by.
In gamma rays.
In gamma rays.
In gamma
And when we
rays.
say observe, gamma rays are invisible. So we're not really observing them.
Right.
And it's not really bright, but we'll take it.
Well, in gamma ray telescopes, and it
Yeah.
was so bright that it almost blinded, overwhelmed many of the gamma ray detectors.
Whoa.
So that's what happened in last year, and this is a very unusual thing. Normally, gamma ray bursts are detected and they're fine, but this was really bright, and again, it was from 1.9 billion light years away. A star that was much bigger than our sun collapsed into a black hole. But as it was happening, as it was going through supernova, as the black hole was in the process of formation, these two jets got created, and the jet just happens to be one of the jets pointing exactly towards us.
Nobody on the Jets is the greatest of all time. I'm just going to say that.
But that happened last year, and there's a new paper that has come out that looked at, well, what was the impact of these gamma ray bursts on our atmosphere? And this is really interesting because there is, so here are these astronomers that looked at some of the data from China's seismo-electromagnetic satellite. And that is to detect changes in our atmosphere due to earthquakes. And just as a context, I should mention, just think about it now. We actually start, oftentimes we talk about results coming from Chinese satellites, Chinese telescopes, and things like that. So this is again one of those instances. And what they detected was that the ozone layer, this is the layer in our own atmosphere, which actually protects us from the ultraviolet light. It's really crucial that some of it actually got disturbed by this gamma ray burst. And so this happened 1.9 billion light years away, but it impacted the ozone layer here on Earth.
So it's not just my hair care products that I used to use in the 1980s when I had hair that's going to destroy the ozone layer. It's distant collapsing stars turning into black holes 1.9 billion years ago, with its gamma rays finally reaching our ozone layer here today, or last year.
And the concern is the same, right? I mean, the reason why those chlorofluorocarbons, all those hairspray stuff, that was in there, the reason that it was the concern was because, if you don't have ozone, then you are getting ultraviolet light from the sun. And here, what happened, it's not like, oh my goodness, this year there has been far more UV light. What happened was, for a few seconds, a few minutes, in fact, that these electrons were stripped out of ozone. Ozone is 3 oxygen atoms combined together. So for a little bit, these electrons got stripped out. And that's what was measured by this satellite as electricity in some sense. They detected that, and then they reformed again. So it was a temporary destruction of ozone. No harm, nothing was a problem. It's not like suddenly you got UV radiated. No, that's not what had happened. But the point of studying this for them was that if a similar type of gamma ray burst, for example, happened in our own galaxy or relatively nearby, then you can imagine ozone layer being disassembled, destroyed, for even if it gets back together, but say for example for a few years, well, that would be extremely damaging. And in fact, there have been some simulations people have done about that, and they think that perhaps once every billion years or so, something like that happens and may have been responsible for some of the mass extinctions. We don't know, but that gets into a lot of speculation. And it's unlikely that there's going to be such a gamma ray burst again within our lifetimes, and certainly within the next few 10,000 or even nearby galaxies. But the point is, it can impact our ozone layer.
So let's say Beetlejuice, which will be eclipsed tonight by an asteroid, is going to go supernova sometime between now and 100,000 years from now. if after it goes supernova, it goes black hole, it could release a gamma ray burst that might destroy our ozone layer, forcing us underground for an indeterminate amount of time and turn us into mole people?
No.
Okay.
A couple of reasons. So even though big stars go supernovae, but not all of them result in a black hole. And Betelgeuse is not big enough to turn into a black hole. Rather, it's expected that it will turn into a neutron star, which I actually mentioned before, but a neutron star which is a little bit bigger than a black hole. I mean, neutron stars is like the, as they say, size of the New York City. And so that's the core that's left. Very strange object, no question about it. And supernova also is going to be amazing, but it's not going to turn into a black hole. And then for this kind of gamma ray burst, it's also that the beam, you have to be in its way, which is the likelihood of you being in that way. It's like very, very, very low. So Betelgeuse is not going to produce gamma ray bursts in the same way as Boat did. And second, it's going
The Brady of all time. Oh, no, right.
And it's far enough. So people have looked at what will happen. I mean, is it dangerous when, or is it going to be dangerous when Betelgeuse goes supernova? And it's far enough away, about 640 light years away, that it would be perfect for a spectacular show in the night sky, but far enough that it's not going to impact life on Earth. And in fact, scientists think that even if there's a supernova closer by, even like 30, 40 light years away, you would be okay. But we don't know. And I would say, or I hate to say that, like there's only one way to find out. but towards the end, if I could just make a connection. But it's interesting that ozone itself, along with oxygen, I mean, oxygen, a lot of the molecular oxygen was produced by life. And it was and through this molecular oxygen by blue-green algae earlier on. And it was the sort of like, interaction with ultraviolet light and molecular oxygen that created ozone. 3 oxygen atoms together. That's what it did. And that layer was formed around 600 million years ago. And before that, all life was pretty much under the oceans because that's what provided protection from ultraviolet light. And this ozone is the one that actually allowed, in some ways, species to come out, both first plants and then also crawling animals from the ocean, and evolution took place. But before that, without the ozone, it was all just under the ocean and microbial life.
So we gotta protect that thing. No more hairsprays with chlorofluorocarbons. And stay away from us. Massive gamma ray bursts from millions and billions of light years away.
And Hairspray, another musical.
That's right. Right? That's with Beetlejuice. When Beetlejuice goes supernova, it's showtime.
Exactly. And so here's the end of the year. Well, this is not the last show of the year, but certainly here is the musical. They throw off the musical shows. Well, this was the musical for the Mr. Universe.